Hello, welcome back. Let's take a look at some confidence interval FRQs here today. I've got a scoring guidelines document attached on Schoology. I'm not going to work through these entire problems. I'm going to more direct you, kind of do some close reading of the text, marking up the text, telling you which direction to go, but I'm not going to actually show the whole four-step process. Hopefully, you're figuring out this chapter is really pretty formulaic. All right, environmental science teacher at a high school with large population of students want to estimate the proportion. Okay, so first few things. I see this word estimate, and if it isn't already, you need to be shouting the word confidence interval whenever you see the word estimate. Okay, estimate means it's confidence interval time. If it's confidence interval time, you can be looking at this uh, kind of formula sheet we made last time. If you don't have this out, get it out. We're going to be referring to this document over and over. So, um, estimate the what? Well, it's going to give me the proportion of students who regularly recycle plastic bottles. That's what goes in your state step. That's P. That's what goes in your state step right there. It's telling you that. The teacher selected a random sample. That's nice. So I'm going to highlight some things that seem important, some conditions, random sample. I'm also going to highlight large population of students. That's going to be for the, what is that large population of students making me think? N less than equal cap n over 10. It's making me think of independence of selection, random sample, pretty clear what that's indicating. To each selected student went into the teacher's office one at a time and was asked the following asked to respond yes or no. The following question: do you regularly recycle plastic bottles? Great. And based on the responses, we made a 95% confidence interval. All right, so that's our confidence level for the proportion of all students who would respond yes to the question, and it was calculated as this interval. Okay. How many students were selected in the sample? Well, how the heck do you know? You've got a margin of, excuse me, you've got a confidence interval here. And that confidence interval has a margin of error, a plus or minus. The first thing you need to do is when you see 95% confidence interval for a proportion, you need to say, what formula is that? That is p hat plus or minus z star square root p hat 1 minus p hat over n. You're trying to solve for n. How many students? It's asking you about n. You need to solve for n from the margin of error. First thing you need to do is find the midpoint. The midpoint of your interval is p hat. Once you have your midpoint, you can go back and say, okay, well, this is my margin of error. Find your margin of error. Then you're going to find n. Great. Part B, given the method used to collect the responses, explain how bias might have been introduced. And people miss the second part. Describe how bias might affect the point estimate. What does that mean? Over or underestimate? Take a moment to consider, is it overestimating? Is it under? What does it even mean? All right. Part C, stats teacher was concerned about the potential bias in the survey to obtain a potentially less biased estimate. Okay, we did an alternative method, put 300 students, and we told them how to respond. In private, flip a coin. Great. If it's head, you say no, no matter what. If it's heads, you say no. If it's tails, you answer truthfully. All right, CI, what's the expected number of students from the sample of 300 who would be required to respond no? Well, how often is it going to come up heads? Half the time. P heads is 1/2. And P is 300 times 1/2. It really is as easy as 150. And part C, the results of the sample showed that 213 out of 300 responded no. Based on the results of the sample, give a point estimate for but the proportion of all students who would respond yes. I'll leave that one up to you. You just figured out how many would have to say no because the coin told them to. Well, if you know that many had to say no, do a little thinking, figure it out from there. There's a scoring guideline I've put together. Take a look at that. Didn't really do any work there. Take a look at the scoring guidelines. Make sure you're comfortable with this. Number 6. All right, here's a goofy one. It's a 6. It's a 6 problem. That means it's going to be harder. That means the later parts of this, you're going to say, what the heck's going on with this? Let P be the proportion of all U.S. 12th grade students who would answer the question correctly. Okay, there's a question about what is this? Oh, it's on the A-push exam. Okay, correct answer is C. In 35 and 36, the Supreme Court declared that important parts of the New Deal were unconstitutional. President Roosevelt responded by threatening to what? Impeach Supreme Court justices, eliminate them, appoint more of them, override the Supreme Court decision by gaining a 3/4 majority of both houses of Congress. Great. Which one do they do? Okay, maybe you know. Let P be the proportion of all 12th grade students who would answer the question correctly. Construct and interpret a 99% confidence interval for P. Okay, 99% confidence interval for P. You got to know the formula. It's for P hat plus or minus Z star squared P hat 1 minus P hat over N. That's in another place. Confidence interval formula down at the bottom of the first page. Statistic plus or minus critical value, standard error of statistic. Well, here you go, statistic, P hat, standard error of the statistic, square root P hat 1 minus P hat over N. And yeah, there you go. So, that's a state plan. Do conclude. Do it. Not a lot to say there. Parts B, C, and D. This is chapter 5 review. Chapter 5 review. You can do it if you want, but don't fret too much if you don't get it right away. We can go over that in class. That might be a great in-person thing to do. I don't want to take up video time talking about chapter 5 review. We'll come back to it later. Don't worry too much. 2005 Form B. Researcher believes that treating seeds with certain additives can enhance the growth of plants. Okay, we got a belief. Believes treating seeds with certain additives can enhance the growth of plants. I'm going to circle the word enhance because that makes me think some sort of increase. We're going to investigate this. We get some Roma tomato seeds. 24 seeds are randomly chosen. And 2 are assigned to each of 12 containers. One of the 2 seeds is randomly selected and treated with the additive. Great. The seed serves as a control. Same container, 24 plants measured after 30 days. Data were used to okay, output below. Okay, graphical data displays indicate the assumption of normality is not reasonable, not unreasonable. What does that mean? There's no skew or outliers present. We can get away with the normality condition. Okay, construct a confidence interval for the mean difference in growth and be sure to interpret this interval. Okay, it's a confidence interval for means. The mean difference in growth, mu1 minus mu2. You have to say, okay, 2 sample t interval, mu1 minus mu2. You can do most of this in your calculator, but you still need to know how to check the conditions that we did: random assignment and selection, independence, and normality. How do we establish normality here? Right side, we're told that there was no skew. We're told that that condition was met. And then it said, based only on your confidence interval in part A, is there sufficient evidence to conclude there is a significant mean difference? If there's a significant mean difference, that would mean that mu1 minus mu2 is not equal to 0. That would mean that 0 isn't in the interval. We've made a decision like this before. Based on the outcome of the interval, do we have evidence that it is or isn't different? Right? So if 0 is in there, that means 0 is a plausible value. Remember, go back to confidence intervals. What do they give you? Ranges of plausible values. So if it is a plausible value, we don't have a lot of evidence to say it's different. But if 0 isn't in there, that means 0 isn't plausible. That means they are different. Take a look at the key. More detail on state plan do conclude. This is a very similar problem. Two shifts, day shift and a night shift, parts produced by the two shifts meet the same specs. Manager of the company believes there is a difference in the proportions of parts produced within specification for the two shifts. Okay. For the day shift, 188 out of 200. For the night shift, 180 out of 200. We're going to construct a 96% confidence interval to estimate the difference in proportions of parts produced within specifications by the two shifts. You got to say, okay, it's proportions, it's two samples, it's going to be a z interval. You got to be calling this to mind down here. Two samples z interval for p1 minus p2 in your calculator. It's called a two prop z int. But you need to know how to get to that. You need to say, okay, it's proportions. It's going to be a z critical value, p1 minus p2. All right. And then based on the confidence interval, significantly different from zero, same sort of logic, same sort of question. We made this interval. Is zero plausible? Is zero in the interval? Take a look at that one. Make sure you're good. That's a pretty straightforward state plan do conclude. You're going to have a pretty straightforward problem like that on your exam. This one you're not going to have one like this in the exam because it's kind of goofy, and I want you to know that parts C and D you're not even prepared to do yet. Tell you to skip parts C and D, but parts A and B you can do. Based on the results of the survey, construct and interpret a 95% confidence interval for the proportion of students in the population who would respond S. And what is the meaning of 95% confidence? This is another 4-step process here. We're using an interval for P, one prop Z int. And then what is the meaning of 95% confidence? Look at your confidence level template, actually right here on my formula sheet. 95% of all samples of this size using this method would give an interval that captures the true parameter value. Make sure you're good with your templates for interpreting intervals and levels. And then we got to make sure, okay, can we figure out where to go? There you go. Margin of error calculations, those show up in as a like an add-on in a free response question. They'll show up in multiple choice questions as well. Skip C and D. All you need to do there is A and B. Take a look at that. You got scoring guidelines. Take a look at those. And the last one to look at is a question similar to 2006B. I'm not even going to work through it, but if you want um, more practice doing a straightforward state plan do conclude, try this one. I've got a scoring guideline attached. I haven't done a lot of work here. I've marked up the text. You're going to find that the challenge in this chapter and going forward is, okay, you're going to have a lot of procedures. Do you know which procedure to use in what instance? Can you use the word estimate to say, I'm making confidence intervals? Notice it's talking about proportions. That should lead you to the left side of the table. No, it's talking about means. Lead you to the right side of the table. Make sure you can navigate your way around the formula sheet. Here's the formula for the confidence interval. If you forgot it, statistic plus or minus critical value, standard error of statistic. If you didn't notice, proportions, that's Z stuff. Means, that's T stuff. That's one important thing to remember. That's a thing that gets confused a lot. What else do I have? Use P hat as 0.5 if unknown. That's about it, though. You're going to find that these are very formulaic, but you need to know what do the intervals mean? What do they generate? Ranges of plausible values. How can we test beliefs based on that? Well, is it in the range of plausible values? There you go. Please don't just copy the formula sheet. Don't just copy the scoring guideline. Try them sincerely. Vocabulary is important, as you've noticed. Send me an email if you got questions. I'm available. Take care. We'll see you later.